Hello people, welcome back to my channel. So far we have seen different types of models in machine learning. That is, we had the decision trees, we had the naive Bayes, and we have SVM, KNN and all. Now these are different classification models. Now we need to use in our machine learning algorithm, and our main aim is to get the more good accuracy or with less error rate. Now how to devise the performance or how to evaluate the accuracy of these models. So that's why we have certain classifier evaluation methods, and so today we'll be dealing with the very first classifier evaluation method, that is we have the holdout method in machine learning. So this is the very first or the primitive or even the basic type of evaluation methods. So with the name itself we can say that it's a holdout, means holding out one particular set, we just evaluate the other data set or evaluate the model. So let us see what this method consists of. So this is the data set that we have. So it has these many instances. Now holdout method, what it basically does is it just divides into two disjoint sets. Two disjoint sets of our training data as well as test data. So the proportion of data or the data reservation is solely based upon the data analysis discretion. So he does the data reservation or how it should be proportionated. So say let us consider this many portion and this many portion. This is 70% to training data, and let this 30% to test data. Okay, now what we do is, with this training data we induce a model, a classification model. Now this model could be anything like decision trees, or it should be, or it can be NBA, that is naive Bayes, or it can be SVM, support vector machine, anything like that. Now our main aim is to just accurately evaluate this. So our test data, which is not seen by this model, so these are the unknown sample, that is the test data. So we just test on this to evaluate the performance. So performance is evaluated based upon test data. Okay, now there are two things in this. So if you consider your training data more, so if you have more of your training data, so what you get as an output, that is more training data, then the model which you induce, that will be very good. That the model will be a very good model, means it will very easily classify each of the instances or the new test instances which it will be getting in the future period. Or if you have your test data more, that is, I don't know about the training data, but I take the test data more and more possible. So what I have is, I have higher chance of or higher percentage of accuracy, or the error rate, the misclassification error rate is very low in this. So these are our two things when we consider the holdout method. So we just hold one data set, that is we have our training data set. So with that we induce the model, and with the test data we just evaluate the performance. Now there is two shortcomings in this technique, or there are other methods, or we know that there are several other methods. So there should be some limitation in this. That's why we devised other methods after this. So the very first limitation is that, or the shortcoming of this technique, that is the holdout approach, is that say this is the proportion. So this was our, graphically just to see, this was our training data and only this much part. Okay, this was our test data. Okay, now what happens is, as you can see, some of the instances, that is positive, 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 positive. So all the positive instances were under the training data, and there were no negative instances in the training data, but it's there in the test data. So if you create a model which only sees the positive instances or the positive class, and it does not see the negative instances, then how you can say that the model created is a very good model? So that is the main disadvantage. That's because we just proportion it into unevenly. So the proportion of this data set is done in an uneven way. So that is the main cause of this. So in order to overcome that, what we do is we just do the stratification process. So in that, just we swap the classes or swap the instances in some fashion, or what we can do is, another possible way is we just increase the training data set till here, that is this much part. So this will be 80%, just consider 80%, and only 10% will be going to test data. Now you can see one negative instance is there in the training data, so it can well be evaluated on this negative instance as well as positive instances. Now second is that you have the interdependence of training and test data. What do you mean by the term interdependence? Means, say you can see the training data set. Now in this you can see majority of the positive classes. So this is over presented in the training data, but in the, that is the test data, you can see the negative classes which are there more, not more, but two of the instances are negative and one is positive. So here positive instance or positive class is underrepresented, but here it is overrepresented. So this overrepresentation and underrepresentation of the test instances happen. That is, you have some instances it's not equal, so since you distributed it in an uneven fashion, and so you have this kind of difficulty in this. So well, that was all regarding the holdout method in machine learning. So hope you guys enjoyed this video. If you got educated watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.